Welcome back. Today we're going to take a look at Exercise 5 with SolidWorks 2020. Exercise 5 actually has to deal with bottom-up assembly modeling. Now, bottom-up assembly is essentially taking parts that were already built and assembling them. So there is something called top-down assembly modeling where you're actually building parts inside the assembly using geometry from other parts. This is not that. That's actually going to be covered. We're going to start to cover that in its basic form in Exercise 9. So if you want, you could go to there, take a look at that. As for this is just bottom up. So let's begin. As you can see on the screen here, this is actually the assembly that we're going to put together. It's a collection of parts that make like a U-joint assembly here. And we're going to go ahead assembling it to make it where we could actually do something that's called dynamic assembly motion, where we'll actually be able to grip this handle and rotate it around. But I'm going to show that to you once we do it. With this one, I have this in just a viewing mode, so I'm not going to do that just yet as a preview. But let's begin. All right, first of all, you're going to want to go to the vertani1.com. So I'll start this off there. So just V as in Victor, E-R, T as in Tom, A, N as in Nancy, U, X as in X-ray, and then don't forget the number 1.com. Should take you to this web page. If not, try typing it again. You might have put in the wrong spelling. All right, now we're going to go to the actual part files area. We could go to instructional manuals and there's the information on that, but we're not going to really need to right now. Let's go to part files. And we're looking at the red column. It's always the SolidWorks files. So you'll find the very top is Exercise 5 parts. Go ahead and select that. And it's going to give you this little message, couldn't preview files. It's in a zip file, which a zip file is a compressed file format. So we're going to have to do a little bit of work to extract the files. So go ahead and hit download right here. And if you don't see download here, up here is a download button as well. Click on download. And it should download in the lower left corner, depending upon what browser you're using. You might actually have it up here, down here, but here I have it. I'm on Google Chrome. I'm going to go ahead and click on sheetmetalbracket.zip. And what we'll see here, we'll see all the files. And all you have to do is click on one, and you could select them all just by holding Control A, and that selects them all. So the Control key and the letter A. Or you could Control select each individual one, which would take a lot of time, which I don't know why you'd want to do that, but that's another way. Or you could window over them by just clicking and dragging a window around them all. Okay, and there's other ways too. Hit Control now, C to copy. And let's go now to the, now in earlier videos I started in the Documents file, a SolidWorks Basics folder. If you don't have that, feel free to start it now. As you do parts, it's a great little area. As you can see here, here's my collection of parts. It's a little portfolio that I've generated in making these videos. And what you do is you right click and create a new folder. And we'll go ahead and label this capital E5 for Exercise 5. Double click on the folder. And while inside there, just click in the screen and hit Control V as in Victor. And it should paste them in there. Now, if you'd like to see larger pictures of these models here, click in the lower right corner. That's a quick way to see what each part looks like. Now, you could squeeze these down, and don't grab the assemblies that are there. We actually want to build it from the ground up. So just leave that where it's at. Let's go to SolidWorks now. Once SolidWorks is launched, you could go to New or File New. Now go to Assembly. This is our first time using the assembly tools. Click on Assembly and hit OK. Now what it does is it brings up the open dialog box. You can browse here and locate your files. It actually is going to the last area I worked in, but I'm going to hit Cancel just for a moment there. Now on the left, you'll see it says Begin Assembly, and you have Create Layout. Now Create Layout, another name for that from other systems. It's called actually skeletal modeling, where you can actually draw out curves on planes or 3D guide curves, 3D curves, I should say, and then attach parts to it and even build it and to design your envelope or the actual, like for example, if you're designing an automobile engine and you have the belt, the serpentine belt, you could actually position drawing just a sketch how that belt is going to be put in and then start building the parts around it, like the alternator and the compressor and all these other neat things. So skeleton modeling is really cool. We don't really get into it in the intro class here. There are videos on it, not typically mine, but we do look at top-down modeling, which is kind of related to skeletal modeling, but for the most part, I don't do a whole lot of that in here. So anyhow, let's get started. Just hit the red X here because I want to start by talking about the assembly. First of all, you can see the assembly one is listed here. You have the history sensors, which we don't go into right now. That's something we'll talk about maybe a later day. But we have here front, top, and right planes. You can actually sketch on those. You can't actually extrude from them, though, inside the context of an assembly. You could actually edit a part inside the context and extrude from them. But pretty much we're going to use those to mate things up. You could draw your layout sketch like we were talking about too. Each assembly has its own origin. And then this mates, it's not really a folder, but it's a mates area. And actually it will contain all of your mates that you add. And mates are geometric conditions that you're applying to surfaces of or edges of the model to lock them in. And basically as you glue or stick your parts together, or what we would call assemble them. So let's begin with this. Up here at the top, and you have the pull-down menus, which we're not really going to use for this one too much, but we have this insert component, hit the little arrow underneath it, and you'll see there's insert component, new part, new assembly, copy with mates. We're just going to go with insert component, which is, the technical term is bottom-up assembly modeling in this case. Now, just as an FYI, the new part is for top-down modeling. We're not going to cover that until exercise 9, but note that in a general sense, most people do a combination, or most designers do a combination of both insert component and new part, so bottom up and top down. Very seldom do you see exclusively one or the other, but this lesson is exclusive. So to bottom up, go to insert component, and this brings us back to where we were earlier. Notice SolidWorks had that pleasantry that it came up and did it automatically for us, so we don't have to go through the menus to do it. So that's kind of neat that SolidWorks does that on a regular basis here. All right, let's go to the documents, the SolidWorks basics, and E5. Now, if we want to see bigger pictures here, we could actually click on this little icon here and drag it up to maybe somewhere around large icons. And we're looking for the very first part is going to be the sheet metal bracket. Go ahead and select the sheet metal bracket and hit open. Now you could see the parts just floating with your pointer anywhere you position it. What we're going to do is I want to show you how you can position it to where it locks in its own front plane and its own top and right plane to the front planes of the top, of the assembly. And basically that means it's locking in at the origin point, and it will disallow it from rotating and moving. And that's a good strategy for your first part. It locks it down. So to do that, rather than clicking just anywhere, click on the green check mark in the upper left. And that positions it right on the origin of the assembly. So your origin of the part and the assembly match up. Now here's where some companies, when they're designing using the top-down method, they have a strategy where they always drop it in on the front plane of the assembly. That way, every part that they build in the context of the assembly shares the same origin. And if you ever get parts from a company that does that, or designs in that method, you can actually just grab the parts and drop them in by selecting the front plane every time, and it will drop them all in at the origin, and it just assembles itself. Now, note that by doing that, you don't get the dynamic assembly motion as a default with that. You might lose that, but you might not need that. Not all companies need dynamic assembly motion. Sometimes you're just trying to assemble it to check clearances and interferences and things. So now we're going to go and take a look at the feature tree on the left here. You'll see the sheet metal bracket is listed there. There's a little F in parentheses, and the F stands for fixed. The very first part, and only the first part, is by default fixed in space. And so if you wanted to, you could, and I don't want you to do this, but if you wanted to, you could right click on it. You would find float, and then you could actually relocate it or just have it floating. But think of it this way. Imagine we're building this and we're holding the bracket in our hand, and as you're putting the parts together, you have to have some way to fix that part down. Sorry, I'm shaking the desk here. And then as you rotate that handle on the top, all the parts will interact with each other. So it's a good strategy. Otherwise, if you're not holding that bracket down, when you go to rotate the handle at the top, everything's going to rotate, including the bracket. So that's our strategy that we're using to prevent that from happening. Okay, now let's insert another component. Now there's several ways to insert components inside SolidWorks. This is probably the most common and original way that it was done since I've been using SolidWorks since 1997. But there's other methods over the years that SolidWorks has incorporated into the technology, which are really pretty neat. So we'll take a look at some of those. Okay, so now we have to pick out the next part. The next part we're going to grab is the yoke mail. So select the yoke mail and hit open. And I want you to move your pointer out on the screen and just to the left of the bracket, click to release the second part, which is the yoke mail. Now, if you look at the little arrows to the left of these parts, you could hit them and you can see there's all the features of that part. If it's a native file, sure enough, you're going to be able to edit all those features. I'm going to hit the little arrow to bring it back up. Don't need to see all that stuff, but I just wanted to show it to you. Now, let's take a look at Move Component right here. Go ahead and select Move Component. Now, grip this part with your mouse button. Hold it down, click and hold, drag it, and you'll see you could drag it through the other model or models if you had them up there. Okay, there's nothing stopping it. Now move it back. Move it back away so it's not contacting the bracket. Now take a look at some of the options here. Now under here you have free drag. If you hit the little arrow, you could position them by delta X, Y, and Z. You could actually type in explicit values for X, Y, and Z to position it if that's what you desired. There's a couple neat things in there. And then you also have rotate. Hit the little arrow to the right of that. And go ahead and grab the part, and you'll see now it will rotate. Now, right now it's just positioned to rotate around its centroid, the center of the model. So you could click and drag. And sometimes that's helpful to get it into position before you start mating, especially if it's somewhat of a complex mate you're applying. You don't necessarily always want the part going in upside down and then flipping it. And there are tools that help you to work through that. We're going to see those. Okay, but let's make sure it's pointing up like what you see here. Now, let's go back to move, hit move, the little arrow there. And so now when you drag it again, it's just floating. Okay, now there's options. There's standard drag, which that's what we're set to. Go ahead and select collision detection. And you'll see below some additional options appear. There's all components or specific components. You'll be able to select them. That's useful if you have a very large assembly and you're just trying to test if there's any collisions or interaction between the parts within the proximity of the part you're working with. You don't need to have them all on because it takes up system resources that way. So you could actually select these components and you'd be able to select like, oh, I want the bracket and I want this and this and that part. But if you let them all, especially if you have thousands of parts, it could slow things down. So that's a nice optimization feature. Let's just go to all components because we only have 2 parts in here anyhow. All right, there's stop at collision. Go ahead now, grab the part and drag it and try and collide it with the bracket. And you'll actually hear, sounds like someone hitting the side of a 50-gallon oil drum. Okay, and it actually stops. All right, so there's collision detection. Now there is under evaluate, there's actually a clearance and interference detection as well. Those are for static bodies. What we're doing here is dynamic. So just be aware you could select those, and once you have a bunch of parts that have been mated together, you could select interference detection and say, show me any interferences, and it'll show them in red. I'm going to try and remember to show that to you later. It's pretty easy, and it will highlight in red where those areas are. Okay, now physical dynamics. Go ahead and select physical dynamics. Physical dynamics, you could actually check a gear mesh with it, but newer processors, it's probably pretty neat to see. On the older systems that I used to work on, it was rather slow, like the meshing of gears would take a long time. A good example of this was I saw a demonstration once. Someone designed a pool table, and they had the cue ball and they had all the balls out, and they were mated tangent to the surface of the pool table. And they went ahead and they grabbed the cue ball with their mouse and they dragged it through the balls, and it pushed all the balls out of the way. Now be aware, it's not going to do any kinematics. There's no moments of inertia. There's no friction. Those things you're not going to see with this tool. Okay, there are tools that you could get that are add-ons, which is SolidWorks Motion, that will enable you to do those types of tests. They're not the easiest thing to set up necessarily. Once you get used to it, of course, it's not bad. But we're not going to cover that in this class. That's an advanced, it's a different module. So just be aware of that. Actually, that would be under SolidWorks Motion. All right, and that's a really neat product in itself. So for kinematics and dynamics, what we're looking at here is just dynamics. Okay. Now go ahead and select dynamic clearance and click on the two parts and then hit resume drag, and this will just tell you how close in proximity they're coming between each other. Okay, and so it can be very useful again if you're testing out your assemblies and such. See how close things are coming. And you could even set a distance, like, okay, stop at a specified clearance. So let's say we want to stop within 0.5, so within a ½ inch of striking the other part. There you go. See, as I push it, once it gets to that 0.5, it stops. I can't get it any further. Okay, so anyway, you can hit escape. Just wanted to show you those tools. They're pretty neat. Now we're going to go ahead and learn how to mate. Now mating is establishing relationships on the surfaces or edges of the models to attach them. And very similar to the sketch relations that we saw, only in the 3D. So this is how you can do it. Go to the Assembly tab, find the Mate tool. By the way, if I'm talking rather slow, it's later in the day, you could hit on YouTube the little fast forward 1.5 and skim through. My coffee's already worn off for the day, so just be aware I might be getting a little slow here and tired. All right, so go to the Mate tool here. Now there's a little paper clip you see. Click on Mate. And here you could actually see the standard types of mates. There's also advanced mates, which we get, and mechanical mates. And we see, like, for example, we'll use the gear mate in the advanced class. We probably won't touch upon the advanced mates or mechanical mates in this intro class. We're going to use the standard mates. Okay, but those are all really impressive. Watch videos on them if you want to learn how to do those. I don't have, personally, I don't have many videos on those. So, all right, let's go ahead. The very first thing we're going to do, we're going to let it pick the best choice for what we select. So see this pink surface right here on the yoke mail? That belongs inside this hole here. So go ahead and select this surface. Now before you apply this, or before you click on that surface, be aware, depending upon the location of your model, yours might turn out a little different initially than mine, but don't worry. Okay, so just give it a moment. Don't hit undo just yet. All right, now take your pointer, now hover over this surface. Now, we've talked about surfaces and edges. To the right of the pointer, you'll actually see, if you're truly on the surface, you see a blue square. That's an indicator you're touching the surface. Now, if you move it slightly to an edge, you see the edge turns orange, and then you get a little line to the right of your pointer. And you might think, well, what's the difference for mates? They do make a difference. Sometimes you want a face, sometimes you want an edge. For this, we're going to do mostly faces. So in fact, what I'd like to do is customize our interface so that we don't accidentally select an edge. Here's how. Right-click in the upper right corner of the screen where there's actually the ribbon, but there's no icons on it. So the gray area of the ribbon, just where I click. Now, go to, hold on a second here. Oh, you know what? I can't do it just yet. I'm going to have to turn off mates. Hit the red X on mates. All right, now we could right-click, and you'll see Customize. Click on Customize. Now you can have icon size. You can change the icon size. All right, tooltips gives you the information as you hover over things. But let's skip over that. Let's go to, let's see here, commands. Or, no, we'll go to toolbars. And I want you to find, let's see here, selection filter. So go ahead and select selection filter. And hit the OK. Now it pops up at the top on here. On older versions, it seemed to appear at the bottom. So I actually prefer it on the bottom. So the one way you can move this toolbar is see the little dot, 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 dot on the upper left there. Get your pointer over those dots. So your pointer will turn to a cross with arrows on it. Grab it with your mouse button, hold it, and just drag it down here to dock it down there. So it's kind of out of the way. If you don't have a lot of real estate on your screen, you could close it later on. You could actually pull out and hit the little X. All right, so now let's select this one, Filter Faces. And notice the fast key for Filter Faces is X. So later on, if we remember to turn off X, because we might want to select edges, you could just hit X, or you could go back down here and disable it right here. Select all filters, or disable it by turning them all off. Okay, so Filter Faces. Now, if you go over an edge, you can't get it. Okay, so just be aware you're going to need to turn this off later on. And X was the key. Click on this pink surface here. Now move your pointer over here. And notice I didn't select the mate tool in advance this time. So I'm going to have to hold Control. So just if you don't pre-select a tool, just note you have to hold Control for multiple selections. So select that face now and release Control. And now let's go to the mate tool. It should move over. It'll actually jog over and appear to be in position. Now yours might be a little higher, might be a little lower. It's okay. It's just one of the constraints that we've added. Now what you're ultimately doing here is you're removing the degrees of freedom, or at least as many as you can. Sometimes when I used to work in industry, we'd remove them all. Sometimes we didn't need to see dynamic assembly motion. Sometimes the assemblies don't have motion, like an electronics part, like if you're designing a phone internally. There's not really much of any mechanisms inside of that phone. It's all digital. So it's microchips and they're static. So a lot of times you don't need to apply dynamic assembly motion to items. All right, so anyway, here we have this. Go ahead and hit the green check. Hit it one more time, the green check. And now grab the part and drag it. Now you'll notice you could swivel it by dragging left and right. Drag it down. You could drag it up. We've essentially removed some of its degrees of freedom here. Okay, remember there's always 6 degrees of freedom. You have X, Y, and Z, and you have the ability to rotate around those X, Y, and Z. So those are the 3. So the rotation around X, rotation around Y, and rotation around Z equate to the additional 3. Okay, let's move this down and get it to where the legs are visible. Now, I'm in an isometric view. If you're not, if you've rotated, hit your spacebar, just go to isometric. Okay, now go ahead and select this surface right here. And notice when you go to the surface, you could go right to mate. Go ahead and select mate. And the part turns transparent so you can see through, which is very useful if you have very large assemblies. Rotate this with the middle wheel. Remember, if you hold the wheel down like it's a button, move your mouse forward. It should rotate underneath. And then go ahead and select this underside of the sheet metal bracket. Now, when you click on it, it should apply a relationship of coincident. All right. Now, the last one I forgot to show you was actually concentric. It picked it. So SolidWorks' little AI going on here is actually quite good. Probably the best in industry from what I can tell. All CAD packages out there have their strengths. This is one that's really pretty neat about SolidWorks, which you're going to see in a minute. But anyway, go ahead and hit the green check. All right, let's hit our space bar and go back to isometric, or Control 7. We'll get you back there. Now hit the green check on the mate tool and grab this leg and drag it. You'll see now it no longer travels up and down. All right, so it just can swivel. So we removed all those other degrees of freedom. We only have 1 degree of freedom here to revolve or rotate around the y-axis. Okay, now we're going to go ahead and add another part. So let's go back to Insert Component. Now, note you could go to Insert Component, but I think I'm going to start showing you some other methods that might really work well, especially if you have multiple screens. This works well. Now, I only have 1 screen on currently that you could see. I actually do have a second screen, but I'm only capturing 1. And on the other screen, I had my actual documents up. I'm going to go to, this is just basically Explorer. You could go down here. You can middle click on it to open a new one. You could go to Documents, SolidWorks, Basics, the E5 folder. We could enlarge these so we can see them better. Now, I'm going to show you how you can just drag them from here too. Now, I've seen students get overzealous and they grab all of them and drag it in. Now, just be aware if you have a lot of parts, you might crash your system. I've seen it happen. Haven't seen it in a while, but I've seen it happen from time to time. And it's just Windows sometimes does weird things. So just be aware, maybe just 1 at a time until you get more familiar with this environment. But we're looking for the spider hinge. Go ahead and grab that spider hinge, and you can just drag it right over here. That's pretty good. And just drop it there. Now let's go ahead and we're going to mate this. So the first mate we're going to add is between this hole that coincides with the, I shouldn't say coincides, it's perpendicular to this blue face here. So select that hole, go to the mate tool, and select the blue hole on the leg. Hit the green check. And hit the green check on mate again too. And let's see what we just did. Now you can pull this out, all right? You can pull it in. Now what we want to do is add another mate, but make sure you add it between the blue face, blue flat face this time, and the blue flat face that's in its line of sight. So example being, you wouldn't want to select this blue face on this opposite side to that blue face, because guess what? It's going to pull through and it's going to be floating on the outside and intersecting partially into the leg. So just make sure you look at your selections before you finish this. So go to mate, select this blue face right here, and then you're going to rotate. Again, I'm just doing that with the middle mouse button, pushing it down, and select this face here. Now, if you did it the wrong way, like where it's actually floating on the outside, you have this tool right here, Flip Mate Alignment. I'm cautious about using it because sometimes if you have other mates, like I already have a mate on there of concentric between the holes. And I've seen it where it's worked before, it actually flipped it, and I've seen it where I flipped it and it's errored out. So I'm just running on the side of caution here. It might work just fine if you hit the flip button, but in my experience of over the years, sometimes it just doesn't behave the way I would expect. So it's great that they have the flip tool, but I'm just not going to use it here. I don't need to actually. Hit the green check. And let's hit the green check again over here, rotate this around. Notice to the right of your pointer, you have that little symbol. If you ever have that little symbol and you're trying to select other entities, you might have just reached over your keyboard or you might have accidentally hit the X key. So just be aware, now you know how to turn off. You just click over here to turn that off. Okay, now let's grab this and you'll see this rotates and it's positioned between the legs of the yoke. Let's drop in the next part. Go to Insert, Components. Now you could go and do it the way I just showed you, where I bring up the other method and drop it in. In fact, let's show you another method. Okay. No, you know what? We'll save that because there's some advantages. We'll save it for one of the pins that's going to go in here. So I'll show that to you. It's really pretty cool. All right, let's go back to browse. Sorry. All right. Now, what we're looking for this time is the yoke female. Go ahead and select yoke female, hit open, just drag it right over here. And you can see now we have red hole to this hole along that red surface, and then the red surface here to the red surface on the back side. So let's go ahead and do those. Go to the mate tool, select this gray hole right here. And again, I have a lot of students that don't use their zoom, and I'm not sure why. Think of it like I used to like to play darts or build darts. And what if someone gave you the opportunity to say, I want you to get a bullseye, and you could go right up to the board. You're going to go up to the board and you're going to stick that in the bullseye. So don't be afraid to use your zoom. There's nothing hindering you. You don't have to have it way zoomed out. Zoom up on this stuff when you select it. It just makes it a lot easier. This is teaching this for 22 years. I'm just saying that because I've seen a lot of students follow this one up. Okay. Now select this red hole. It doesn't really matter. Any red hole on that yoke female will work. And you'll see it will align. Hit the green check. Now let's rotate this around and select the red flat face of the yoke. Rotate this so that you're looking at the other side. Don't be lazy and select this side. That's not the way to do it. You got to rotate it around, get this side so that it contacts. Hit the green check. All right, looking pretty good here. Now, let's grab this plunger down here and drag it up a little bit. Notice I'm rotating around a little fast here now. I'm assuming you kind of know how to use the tools pretty well. So forgive me if I'm going a little fast for you. If those of you who've gone through the studies like exercise 1, 2, 3, 4 and the labs, you're way up to speed. Some of you I know don't always have the time to do that, so I might be going a little fast for you. Okay, now select this pale green surface on the underside of that plunger. And then go ahead and select this surface right here. And notice on the left, it actually selected parallel. That's one it hasn't done yet. It's done coincident. Coincident is face-to-face contact. Parallel allows it to align itself, but at whatever distance it is. So parallel is a very useful thing, and SolidWorks AI automatically knew to do that. The latest and greatest systems out there, as far as I know, SolidWorks kind of holds the crown right there, and that's why I said this is pretty impressive that it could do it. SolidWorks is the only one that I've tested within the past couple years that when I do this particular assembly, it knows to automatically pick parallel for us, which is really nice. Not all systems can do that, but I'm sure they will. They might already do it for all I know. Okay, hit the green check. And hit the green check again here. Now, those of you wondering what this is exactly, it's a widget. It's just a mechanical U-joint to show how to mate, and it's really not much to it. I just had a little fun designing it, that's all. Okay, let's hit the space bar, you can go to this little polygon right here. It's kind of a backwards isometric view. Grab this yellow flat face here and drag with your mouse button depressed. And make a little circle, and you can see this is what we call dynamic assembly motion. All right, you can see the parts interact with each other. Even though we don't have the pins in there yet, it's still working, it's functioning, because those degrees of freedom have been removed and because of the mates that we've added. All right, let's add some pins. Now, this is where I want to show you a really neat little capability here. If we go back and we bring up Explorer, remember it's just down here, you can middle click, bring up a little window, go to your documents, and wherever you put your files, I put them again, my documents, SolidWorks Basics, E5 folder. And here's a red pin, and I'm going to zoom up with this up on the screen. Now watch this. This is, oh, you know what? Just double click actually on the red pin. What it's going to do, it's going to ask, how do you want to open this? Select SolidWorks Launcher and hit OK. Now it's going to open up the pin here, zoom up on the pin. Now it's opened up by itself. Now go up here to Window and find Tile Vertically. And now it should spread the two out. So we just opened up the pin by itself. And this is just another method of inserting parts. Now there's a neat advantage, a distinctive advantage you have with doing it this way. It's not always practical to open every single part, by the way. But if you have it available, this is what you can do. Watch. I'm going to zoom up on this hole right here. I'm going to grab the shaft of this pin. And I'm going to drag it to the hole, the red hole. Notice to the right of my pointer, and notice exactly where my pointer is. It's on the actual red surface of the hole. And I get two little cylinders stacked. That's a good thing. It's adding a concentric mate automatically for you. Release, and then hit the green check. Now, you can maximize the assembly. You could click on the maximize button here, or you could double click on the blue bar at the top. Either way. Now grab that pin and you could drag it in, kind of get it in there like so. All right. If it rotates on you, that might happen a little bit. Just rotate it back or whatever you need to do. Okay, now what we want to do is we want this pin to be stuck in here to where this surface is aligned to that outside surface of the yoke. So here's what you can do. I'm going to hit escape. I'm going to go to mate, and let's see what SolidWorks picks out for us. Now note, you could pre-select what you want here if you knew exactly what you're doing. But for a learner, watch this. This is kind of neat. Click on that blue surface there. Or, not blue, it was red, now it's blue. Now select this surface that I'm hovering over on the yoke. And it pushed it in. Now, look at what it picked for us on the left. It picked tangency. So again, that's pretty neat that the AI kind of picked out what the best solution was for us. Mind you, it's not always going to do it right, but in these cases, it does a nice job. All right, let's hit the green check. The green check again. I'm going to insert the parts the more traditional way. Well, you know what? Actually, let's bring up, however you want to bring up the next one. Now the blue pin, drag that in close in proximity to the blue hole. All right, now I'm going to show you another technique for mating. Now, you notice I dragged that red pin in, but we had opened up that pin. We went to Window Tile Vertically, and then we dragged it in. And you get that auto mate. Now, here's the auto mate that we're going to use, but you have to hold the Alt key down on your keyboard. So hold Alt. Now, grab the shaft of the blue pin, and if you're not zoomed up, it's going to be difficult, so I'd recommend hitting escape, zooming up as close as you can to these before trying it. Okay, if you're ready, now drag it into the hole. Now notice I'm holding the Alt key and just getting it into position. Release the mouse button first, then release the Alt key, hit the green check, and you just added a mate. So the Alt key can add a selection of mates as well. All right. Now the tangent mate, I'm going to try it. I think last time I tried it, I don't think it automatically worked. So I'm going to hold Alt and see if I could get this. So Alt, drag that to the surface, and sadly it doesn't. So that's asking a lot though. Okay, so don't get me wrong. I don't think any system can do that. But let's go at it more the regular way, the mate tool. Select this face here, select this gray face of the yoke male, and it picked tangent again for us. All right. So I really encourage y'all, once you build a part, if you're going to try it again, try different methods like that, like where I just tried to see if that tangency worked, because I can't tell you how many times, even though I read with every release, SolidWorks, every year they have a new release, and they have anywhere between 150 to 250 new features or enhancements that they add. And I'll scan through them. I don't do them all. They actually, you could watch their webcasts on it. but it's very useful in this type of situation. Okay, so now I'm going to go ahead and hit the green check and rotate this. And here we could see there's some holes in here. There's actually some that we want to put in a set screw or set screws. So let's go to, let's do our other method here, bring this up. And, you know, we could just double click on the set screw and then zoom up to it. Go to Window, Tile Vertically. Oh, and I have that red pin, which we don't need. Close that. You could save it if you like. And now let's go to Window, Tile Vertically again. And zoom up to the hole. Grab the thread. Now that's a cosmetic thread on that surface. So hold Control, grab that cosmetic thread and drag it in. And sometimes you'll see that the actual, the wrong face ends out. Like see here we have the set screw, the little hex in there. It turned out just fine on mine, but on yours, sometimes you have to flip it, move it around. If you're using the other method, actually, I believe the tab key will pop it in and out. Let's see here. Or you could use this one right here, the flip mate alignment. So you could use it afterwards if you like. Hit the green check. Now this surface here, let's see if we could use that Alt trick. Alt, select this surface to that, and let's pause in here. All right, so it actually ended up, it took a second there, which was interesting. So I'm going to hit the green check. Now I'm going to try that again. This time I'm going to try with the tab key. You know what? I don't have to hold Alt when I drag this in, by the way, because we have the sides separated. So my apologies. Again, my coffee's worn off for the day here. It's getting a little, it's near 5 o'clock, near quitting time. Okay, I'm going to drag this over here and try hitting the tab key, and you'll see it will pop it in or out. And you can see there's no hex in there, so I have the tab to get in there. So I'm going to hit the green check, drag it down a little bit. Now get on that surface, and now you have to hold Alt. Drag it to this surface. Now, there is a tool that enables you, if this were patterned, which I don't believe it was, but there is actually a way to drop fastener into the original and then have it follow the pattern and automatically do it. But this is just good practice for you. That's a more advanced lesson for a future date. So let's try it again. So grab this, drag it here. We don't need to hit the tab key. Lock it in, hit the green check. Grab the surface. What key do we hold? The Alt key. Drag it to this surface here. Oops, I held Alt too late. Oh, there it goes. Okay. And then finally the last one here. Drag it over. Release it. Green check. Now hold the Alt. Depress your mouse button. Drag it to that surface. And align it. Okay, so you got some good practice. I'm going to close that set screw. And I'll save it. Do you have to save it? No. But in this case, I'm saving it. All right, now we could go ahead and bring in the handle. Now the handle, what's unique about the handle, it's actually a subassembly. And meaning, i.e., it itself is an assembly, just a small one. And sadly, when I made this, I named the shaft of the handle. So you have a handle part, you have a handle top, and then you have a handle assembly. So it might get a little confusing here. So my apologies. Let's go ahead and insert that. Let's go to Insert Component. And if you don't see the handle here, note these are the quick filters. Like you could filter assemblies, and then there's the handle, or filter parts, or whatever, you know, or both. So I'm going to click on the handle, hit Open, drag that up here, click to release it. Okay, so now we're going to go ahead and add a mate between these concentric faces of the pink shaft here and the pink hole. So go to Mate, select this pink face here, and then the pink face right over here. Those of you who are colorblind, my apologies. My son's colorblind, so that might be difficult for you to see. Hit the green check. Now, drag this up a little bit and then release it. Make sure that this box is cleared out. If not, right-click and clear selection. Now, see this little flat? Now, there's there's a yellow surface here. That's the flat surface you want. That's for the keyway. Without the keyway, this won't work. So you have to select the flat surface. Now, be careful. This is a rounded surface. Stay away from that one. The flat yellow surface. Click on that. And then rotate this around and make sure it's the flat yellow surface for the key on the shaft. Okay, it should align those two. Hit the green check. And finally, a mate. Let's go with a distance mate. We'll pre-select it. Now, you don't have to pre-select it, by the way. You can post-select it too. But let's pre-select it just for the heck of it. Set it to 0.01. We're going to have a little distance between the top and the bottom of the top surface of the bracket to the underside of the handle shaft. So select this surface here, rotate around, and select that green ring right here. And hit the green check. And look at that, there's that little gap that you see between. That's what we added. Now that's a very realistic approach. Remember, when you're designing things, you design in tolerances. And SolidWorks does actually have tolerance stack analysis, so you can do Monte Carlo simulations on stack analysis, roll up, roll down. We're not going to cover that. That's an advanced, that's a whole module in and of itself. There's videos out there, I'm sure. I don't ever cover that, although I got training for it. It is really neat stuff, those of you who need to do tolerance stack analysis. Okay, hit the green check. All right, so now we could do our test. Grab the handle, drag it, and if everything rotates, you did it correctly. Okay. Now what we're going to take a look at is how we could animate that. Let's say we want to make a little video on how this works. Okay, what you do to make a video, go click on Motion Studies tab at the bottom. Now, you have some tools like for Animation Wizard. These are really nice. It enables you to do things. You even have gravity, motion study properties, contact, spring, and motor. We're going to use motor. Now over here you have a component direction. Go ahead and select this boss right here. And make sure you click on it, highlights blue, and you'll see a little red arrow. And it's going around. Now over here you have the ability to flip it. I don't think if you click on it, I don't think you could flip the little arrow from there. You have to click over here to flip it. Okay, there's rotary motion. There's also linear motor. So if you're doing a hydraulic cylinder or pneumatic cylinder, you could do that too. Okay, now the constant speed, we'll leave it at 100 revolutions per minute. Notice there's distance, oscillating, segment, data points, expression. There's a lot of really amazing stuff you could do in here. Okay, now with that, let's go ahead and hit the green check mark. And you'll see on our timeline, it's going to run for 5 seconds. And now we could go ahead and zoom out here, and we could hit play. And there you can see it rotating. Now, it's a little on the jerky side, but let's try and fix that. Now over here, you have Animation Wizard. Let's try the Animation Wizard. Click on Animation Wizard. Now notice you have Rotate Model. Now that's to rotate it literally in space. So if you wanted to add that, that's the only option we have here. But we're going to learn how to explode things on the lab in just a few minutes here. You would actually have the explode and collapse available, so you could show how things are assembled or disassembled. You could import these motion paths and things like that. We're not going to go into those details, but hit next. And we could say, let's rotate it around the y-axis. And the number of rotations, let's have it set to 1 clockwise. Hit next. Now this is going to overlap our existing video. And the duration, we'll have it for 10 seconds. And the start time, we'll actually start it a little bit after our other thing here. So the start time, let's set it to only 1 second. Okay, so it almost starts like, it'll sit there. You'll start seeing the handle rotate, and then it gives us 1 second, and then it starts rotating itself. And the handle will probably start. The handle will only last 5 seconds. So anyhow, so it'll rotate for additional 5 seconds after that. Hit finish, and let's hit play again. Right over here, this is play from start. And so we see it rotating, and the part's actually rotating, and the assembly is moving. Oh, and it actually kept on and extended our rotation. I didn't expect that, but I should read up on it better next time. Okay, so, and these can be adjusted. These little arrows you could adjust, and let's say you want something to move and another thing not to move. Oh, and also I forgot to put in a second blue pin there. I just noticed that. So if you want, make sure you put that pin in, those of you who are doing this from home. All right, since we're done with the motion study, to get out of the motion study, oh, one last thing. To record, hit Save Animation right here. Now you have the ability, you can save it in that same folder. We could call it E5 video, and you can save it as a Microsoft AVI, a Flash, MPEG-4. There's a whole bunch of series of images if you want to recompile them in another software. And remember, you can make very large, you can make 4K images and things like that. So there's a lot of really neat things you can do here. I'm just going to go with the Microsoft AVI. It works almost every time. And we'll see the render. Now, this is neat. Some of you might not have PhotoView 360, remember. It's in SolidWorks Premium or Professional. Anyhow, if you don't have it, you won't see it. But those of you who do can actually have it photorealistically render each frame. So it's crystal clear and it looks real, almost looks real. So it's pretty impressive it can do that. Note that it takes a long time because as you've seen before with the render, it takes a long time to render each image. Now I have 32 threads running here, so I theoretically could probably do a quick one. I better not. It still might take a while. Now the image size and aspect ratio can make a difference. You could make it like 800 by 600. I don't need it to be particularly super large. Okay, and we have frames per second. Now 7.5 frames per second is pretty bad, poor quality. Though, again, the reason why it's there is so those of you who have slow computers could get a video done really quick. I'm going to make it 30. Like old television sets used to have a refresh rate of like 29.8 frames per second. And so I'll go with that. But those of you who are gamers, of course, know you could get way up there, 60 frames per second, 120 if you want, for that liquid smooth appearance. Just note that stacks time exponentially. So it could take a long time to render those. Go ahead and hit save here. Now, the compressor, you'll see it has several different compressors here. I have some additional ones because I use software from TechSoft, Camtasia to make these videos. And so I have these other compression methods. The Microsoft Video 1, if you're unsure about something working, Microsoft Video 1's old. It works on pretty much any computer. The quality is not going to be great. You could improve the quality, set it up a little bit higher. It's not anything to write home about, but it works every time, or pretty much every time, unless you set the quality too high. Let's go ahead and hit, we'll leave the compression quality, we'll bump it up to 100. And there's underneath configure, just temporal quality ratio. I actually don't know much about that. And you can see how old this compressor is, 1992. So that's why it works pretty much on everything. Go ahead and hit OK. Motion study results are out of date. Do you want to recalculate them? Yes. All right, so it's making the video. Now you see it actually recentered itself and it's rotating here. And it's recording the video as we make it at 30 frames per second. So it should actually be quite smooth when we look at the video and preview it. Imagine it having to render each frame though. That could take a long time. But if that's what the job is doing, then that's what you have to set it to. Okay. All right, so let's take a look now. I'm going to go to my folder, and there's the video. I'm going to double click on it. Oh, I'll be darned. says the video format's not supported on my computer here. Anyhow, I'm not going to go through and redo it, but note that you could select a different compressor on that list and it will work. Surprisingly, it didn't give me an error message on this. Is Windows 10 latest edition, so I'm not sure why. Apparently it's just not supported anymore. Okay, now let's do the lab. The lab, again, those of you who are learning here, I recommend trying the lab on your own, but there are some differences here. So if you want to step through it with me, watch me do it first and then try it on your own. That's not a bad strategy. Okay, so if we go here to part files, this time you're going to want lab 5B. There used to be a lab 5A. I took it out because it was really basic, and lab 5B just seems to do a nice job. So lab 5B, download it. Again, it's compressed. And interestingly enough, it's actually the assembly for the part that you did if you did lab 4, which is out of the last exercise at the very end. It's an Bluetooth MP3 headset. I scaled it up in size just so I could keep the dimensions easy, but just be aware that's what it is if you're wondering what it is. Okay, here's the lab 5B. I'm going to click on it. I'm going to go ahead and select these. Remember, Control A will select them if you want. Right click. You could cut them out of this zip file. Also notice you could go up this direction too. I actually just find students find this easier. You could click on compressed folder tools and select a new directory. Some students might like that. Just be aware, I do it this way just because of 22 years of teaching this. It just seems like it resonates better with many of the students. So I'm going to cut these out of here. I'm going to go to my, let's see, the SolidWorks Basics. I'm going to make a new folder. And I'm going to call it L5A. Double click in there and paste. And I actually believe they are in a folder. If you were to extract them, it would extract into an L5A folder, but not a big deal. Okay, so we can see here there's the parts. And interestingly, oh, there it is, the L4 front bezel. Now, those of you who are in my class and you're turning in your assignment, note that that L4 front bezel, if you use that for your lab, technically that would be considered plagiarism because that's actually mine. You need to make your own. This one is very different than the one that you made in terms of the enhancements that are on it. So it stands out like a sore thumb. So if you're thinking about using any of my files, be aware plagiarism, its penalty is failure of the course. So just spend the 20 minutes to make the model. You'll be a lot better off. Okay, so let's get started here. Now, I don't think I need to go back to model here, but I'm going to go to File, New, Assembly, and hit OK. I'm going to start to assemble that. Now, the drawing is actually in the instructional manuals. So if you go back to Vertanu 1, instructional manuals, go to SolidWorks Basics, and it should be page 40 something, I believe. Oh no, here it is. Oh, it's actually page 63. All right, so there's the assembly. If you want, you could download it, and then you're able to actually rotate it. Let's see, is there a rotate here? Nope, no rotate. So you can see here's the back, here's the front. This is a light pipe. Here's the batteries that are stacked in this little battery shield. There's a little tab on top of there. There's a circuit board. We got to put those together. There's no movable parts in this, by the way, so don't worry about dynamic assembly motion. Okay, so I'm going to go to Browse here. I'm going to go to SolidWorks Basics, L5A. And I'm going to take the very first part, actually, I'm going to take the rear bezel, L4 rear bezel, and just hit the green check to drop that one in. Now I'm going to go to Insert Component, and I'm going to grab the, I'm going to enhance the size of these so I can see them better. Okay, there's the L4 PC board. Okay, now you could drop that in. If you were to hit the green check mark, it might actually snap right into place. like I was telling you about that little trick, but I'd like you to learn how to mate them. Take the time to learn how to mate them. So I'm going to click over here. All right, now to mate this, remember I showed you the little trick for the Alt key, or you could use the mate tool. So if you use the mate tool, select mate, select the underside green surface of the circuit board, and it's going to rest on one of these posts. Hit the green check. Now you can select this surface right here to the post here. Now this will spin, so you have to lock it in. So the gold ring post, or the gold ring hole, is the one we want to lock it into. So this hole here to the surface here, and that should lock it down. So now at this point, we could add some of the additional parts. So let's go back, hit the green check mark there, go to Insert Component, and select the battery shield. Open that up, click to drop it right there. Now let's try that Alt trick. Hold Alt, grab the outside of the battery shield, and drag it to this surface on the outer surface, the OD of that rubber grommet. And it should go with concentric by default. Hit the green check, drag it up. And this next one, I would just go to mate, select this surface here on the top of the rubber grommet to this surface right here. And that should get it sitting on top. Now the battery stack. Insert Component, find the battery cell, open that up. If you get this, it's just the font. I don't have that font anymore that was on the logo on the battery. So just use temporary replacement font. Hit the green check. All right. And so now with the battery, we'll mate the underside surface of it. This is what I was talking about, like the logo on there uses a font that I don't have anymore. So hit the green check here and the green check there. Now you could select this ring to this outside surface to lock it in position. Now you could stack those if you like, additionally just to practice, but I want to show you another little neat technique. This is an advanced technique of patterning the battery on top of itself. So click on the battery, that's what we want to pattern. Go to Linear Component Pattern up here. Now the spacing, set the spacing, these are 30 thousandths thick. So 0.03, and click up here for the direction. Now the direction is just a vector. So this line off the edge of the battery shield we could use because it goes straight up. Now it's pointing down, so we'll just have to hit over here the little reverse switch. And now the number of instances, bump that up, and you'll start to see them stacked on each other. And let's see. Maybe they're not 30 thousandths thick. Let's see, 0.06, maybe they're 60 thousandths. There we go, sorry, 0.06 thick. So 0.06, 4 instances, make sure that's flipped so it's pointing up. See, if you flip it down, they're on the underside. And hit the green check. So that is a linear assembly pattern. Now let's bring in the next part. Insert Component, the connector, drop that right there, and drag it up a little bit. Let's go to Mate. Now you can select through a part by right-clicking, and you'll see the Select Other, and it will select the underside. Rather than rotating, that might be easier for some of you. And then go ahead and select this top surface here, hit the green check, select this concentric surface to the outside surface. There we go. Hit the green check. Now this little notch here, I don't have that actually positioned. It should be positioned straight forward. If you really wanted to, the smart thing, because there is a little notch for it to fit in, is to align it to the notch in the actual cover. But you don't have to do that. All right, now Insert Component. We're going to grab the light frame, open that up, drop that in. Now here's the thing, with transparent components, this is transparent because in real life it's transparent. Notice if I try and select it while it's over the actual other parts, SolidWorks defaults to selecting through transparent objects. Here's the trick to select transparent objects if there's something behind it. Hold Shift on your keyboard. and then it will select the transparent object first. So just be aware that's a little trick if you need to move it. All right, I'm going to get this over here. I want to align this. Actually, I could just align this to the posts. Now, these posts are going to align to the openings on the antenna array. So I'm going to go to Mate. I could select the outside here to the hole to align it. And then you probably want to align this one too because it is free floating still. So you could get this face here to that hole. Now you got to select the underside to this surface. So I'm going to rotate around, select this little underside right there to the green floor. There it is. It's locked in. Hit the green check. Insert component. Now if you want, you can try to align the L4 that you built and see if it fits. It'll actually tell you right away if you didn't design it right. But beware, there are some design enhancements I had to make on the L4 cover that we're going to use that's in this group of this assembly. So it is a little bit different, but the size technically is the same, and I think you could mate it up. All right, let's give it a shot. L front for bezel. Drop it right there. And I'm going to go ahead and go to Mate, select this surface. And you can select this surface right here. The tapered surfaces actually will function. All right, now we need to align, let's align this concentric face here to this face. And finally, close it up. I'm going to actually, there's a little gap, so I'm going to select this little ledge to the top of this surface right here. Hit the green check, and we've got it. Now let's explode it. To explode an assembly, what you do is right over here you have exploded view. Select exploded view. Select the front cover first. It really doesn't matter what you select first, I suppose. Go to the Z arrow. Now you have to be careful here. Make sure the arrow itself turns blue. Whatever arrow you're going to pick for a direction needs to turn blue before you start dragging. Otherwise, it'll drag it in the wrong direction. So especially working in an isometric view like this, it's difficult to ascertain exactly, for some of you users, what direction you're pulling it in. So drag that forward. You see a little ruler. Drag it out about 3 inches. Now grab, now before you do that, hit Done over here on the lower left. Now click on this part. Grab the Z arrow, make sure just the 0 turns blue, drag it backwards about 3 inches. Hit Done. Now we want to select the light frame. Anyone remember the trick? What key you have to hold? Shift, and allows you to select it. Oops, I actually selected everything. I'm going to right here, I'm going to hit this undo. Okay, got to drag that one back again. 3.5 actually this time. Hit Done. You could also select the transparent object with nothing behind it, and it will allow you to select it. I'll drag that forward. Hit Done. Grab this part. Grab the Z, drag it backwards. Hit Done. Remember, if you fail to hit Done, hit Undo up here just one time. Don't hit Undo too often. Okay, click on this. Drag that back. Done. And we'll break up these batteries. 1. And this is good practice for you. 2. Done. 3. Done. And click on this. And now we're really done, so hit the green check. Okay, so we have our exploded state. Now there is also, under exploded view, you have exploded line sketch. Click on that, and you could select like this outer ring here. And you can see the little arrow. Flip the arrow by clicking on it. Oh, darn it, I got a double arrow. Let's clear this out. Hit clear selection. Select that edge. Now what we want is that to flip. Let's hit reverse. There we go. And now select this edge here, and you'll see it go straight through everything. Okay, hit the green check, and that gives us our exploded line sketch. Now, let's animate it. Go to Motion Study, and we're going to go to Animation Wizard. And look at that, we have Explode or Collapse. So if you want to show how something is assembled, go ahead and select Collapse. Hit Next. And the duration, let's have it 9 seconds. Start time, we'll have it start immediately at 0. Hit Finish. And we could hit Play. And there we could see it. Now it's remembering my 30 frames per second. So it's very smooth right now that we set up. Now you could also have it reciprocate and do other things, but let's go ahead and actually let's give it a shot. Watch this. Go to Animation Wizard again. And now if you wanted to delete that last path, if you don't like it, you check this and you could restart over again. But now watch this. Now we'll have it explode. Hit Next. And now the duration is 9 seconds, and it starts after it's finished collapsing, so it's going to re-explode again. All right, and so let's hit Finish. And now it's added the reverse. Let's hit Play again. So we see it, now it's exploding. We should hit Play at beginning to see the whole thing. I'm going to hit Stop. Now to record it, just go to the Animation Wizard. Oh, I'm sorry, cancel. That's the little film strip right here, Animation. And you could set it up. Let's go, again, 800 by 600. I don't need it really, I don't need a large format. We'll do 7.5 frames per second just to get it done. The aspect ratio, 4:3. And hit Save. We'll just keep the same name. I'll use the Logitech video. Let's see how that compressor works. Hit OK. Yes, to let it recalculate. And basically it'll run through. It's going to take a long time. I'm going to end it right there. That concludes exercise 5.